I'm Michael Kohler from Fuse Technical Group, and I guess I'll start my presentation by saying I'm not a broadcaster. And that's sort of the fun perspective I offer on this at the National Association of Broadcasters, is I'm someone who has been trying to figure out how I can use SMPTE 2110 in live event and live production workflows, and figuring out all the things that do work or don't work, and why can't I just do this yesterday is basically sort of my question. So I start with the rhetorical question, why is the cat screaming? And the cat is trying to transition from baseband video to IP. And if you were smart, you'd be screaming too, at least if you work in our little world. But I'm going to talk very briefly about some of the challenges of live events that maybe separate us from broadcast in a different way. So there's just never-ending creative changes. And we get clients and designers who they'll basically send you a link to Instagram and say, I want to do something never before like this. And then they just show you something somebody else has already done. And it's this constant duality of trying to do something that's never been seen, is bigger, more impressive. It's literally showbiz. Everyone's trying to one up everyone. Everyone's trying to have the biggest, coolest 5 minutes of fame on social media. So the screens are getting bigger and higher resolution, insanely shaped. There's impossibly shorter timelines because, of course, it's no longer acceptable to spend a week producing something. They want you to put it in a day, do the show, and then take it down the next day. And of course, like everything with shrinkflation, the budgets get smaller and smaller and smaller. So they want to do these impossibly grandiose shows on an impossibly small budget. So we have all the pressure of broadcast, but with none of the budget. And it's great because when you're doing a broadcast facility, you build these wonderful, future-proof, incredible systems. I've worked on a couple broadcast install projects where it's every I is dotted and T is crossed and thing is drawn on these beautiful prints that conform to the standards. And it's you don't always get to do that in live events. You need to take a bunch of kit off the shelf, assemble it into something, go run, do your show, take it back to the shop, tear it apart, and do something completely different with all the same pieces. So we ran into this with KVM system vendors. It's oh yeah, it's really easy to use our software. It's not if you have to do it 3 times a day and you're constantly reorganizing it. It was this sort of configuration nightmare. And when we're designing systems and figuring out what to purchase for live events, we're always looking for ways to simplify that process. So let's look at some of the reasons people are transitioning to IP. And the first is scale. So this is a picture I took when I was doing some wiring. The spool on the bottom is a 5-wire SDI snake that can basically carry 5 SDI signals for 1,000 feet. And I put the appropriate amount of MTP fiber on top, lengthwise, and those little bags of yellow fiber cables can carry 20 times the video of the cable in the giant spool. And it weighs a lot less. And I've got the picture of a back of one of my computers that has a Bluefield 2 DPU in it with a 200 gigabit network port. So in theory, I should be able to get 16 streams of 4K 60 video out of that one port. And that's unimaginable when we're looking at our normal media server type computers that can do 4 4K outputs. You can do 4 times that amount of bandwidth with an optical network connection. So there's obviously huge wins there. But the reality check from the live events world is, we can have really complicated scale, but we can't plan for it the same way you would in a giant future-proof broadcast venue where you have your matrices in these dedicated air-conditioned server rooms. Our stuff is in racks on wheels, and usually there's either water, dust, fog, or both. And at the end of the show, we got to take everything apart. So it's really hard to convince any given production that they want to pay for this better future-proof thing, because their show it's not about being future-proof. Their show's done tomorrow and you're moving on. So there's this interesting cost-benefit thing that doesn't make the same amount of sense when you're building for a live event. The other thing is cost. So I witnessed this conversation go down at some point where the marketing people who were selling you this equipment for network switches and for SDI routers started describing the bandwidth of their devices in terabits. And I was used to that in switches. I was okay, yeah, I'm trying to figure out how much data I'm moving. But then I heard SDI vendors be oh, this is a 1.2 terabit SDI matrix. And I'm oh, it's all the same stuff. And at some point, that's sort of when it got in my head that it's like, bandwidth is bandwidth, and you just happen to be transmitting video over it in one of them with these weird connectors that like twist in as opposed to like nice God-fearing Ethernet connections. So the reality check for us, of course, is yeah, there's these expensive, highly optimized data center grade systems that the AV and IT companies are going to sell you, and they're really, really expensive. And it's really hard to convince anyone that their production or their rental shop wants to be the one to like bite the bullet and buy this first, especially for such ephemeral, short-lived things. So the other reason broadcasters like to transition to IP, we don't need engineers anymore. We can just use IT people. So your friendship with engineering Michael with the train hat is ended, and now IT Michael, the wizard hat, is their best friend. But the unfortunate reality of that is you actually need something else. You need the unholy hybrid video IT engineer. And they're always wearing multiple hats. In this case, I've got the stylish frog hat and the wizard hat on, but I have more I can swap in. I've got a Captain Crunch hat somewhere. They're ADHD, so they do HDMI and DHCP, which is, at some point, it just all becomes acronym soup, so you can do anything you want. He's got a wizard hat. He's the IGMP snooping guy, and everybody, when you hear that phrase, they're like, ooh, is he reading my email? And it's like, no, that's not what that is. And how do you even train someone in the dark arts of networking? So from the live events perspective, it's not like you're getting rid of one thing and replacing them with another thing. It's like you don't have either of those things, and you're desperately trying to train your staff into something that can like deal with both of those worlds. So I guess my key point here is that the reasons broadcasters transition to IP aren't the same as they are for live events, but there's definitely some promising things for us in the live event space that I think get overlooked a lot in some of the simple things that get mentioned that work for other industries. So like the first is, one, everything is getting cheaper, and there was going to be a bunch of pictures of things I bought on eBay, but apparently that's not maybe the best thing to advertise. But like, what's great is like you can buy all this like weird old data center stuff on eBay and like build a lab to like learn how this stuff works. So part of the question of how do you train your staff or how do you transition into it, it's like, you find somebody who's interested in this stuff, and all of a sudden you've got your Xbox running over a SMPTE 2110 converter to your TV in the other room, and yeah, you put in your AirPods and you don't worry that the network switch is really loud. Like someday that'll fix itself, I hope. But my point is that obviously at this show there have been announcements of new and exciting products that dramatically drive the cost of doing IP down, and that's going to be really appealing to us in the live events market, even if it has weird interoperability quirks with custom codecs, or all of a sudden you're going to have to do routing from your network switch with buttons. Like I'm so excited that my network switch is now going to have a take button on it. That's obvious. I've been screaming at Netgear for that for years, right? No, I'm kidding. Anyway, the other benefit for us is the flexibility. So like, there's a bunch of things that SMPTE 2110 doesn't define, and in that lack of definition is really important for us. So it doesn't define any specific resolutions, frame rates, or even how many outputs a computer can have. So I get to the utopian dream of SMPTE 2110 for me. I've got a bunch of headless computers that are all rendering stuff. They go on a giant network, and then they go to my screens. It doesn't matter what size the screen is, what the shape is, the resolution. The computers are sending out the right video, and the LED tiles are picking it up. Right now, we've got LED processors that can take these signals in natively, but if we look at how everything gets cheaper hardware-wise, eventually the thing that receives these signals is just going to be inside the LED tiles themselves. And if you extrapolate back from that, like, you don't need LED processing, you don't need matrices, you don't need multi-viewers. You just need the ability to have computers generate these signals and have other computers receive these signals. And you can kind of go even further with that to the idea of reduced hardware complexity. So we don't need video output limits on servers. We just need to know how much bandwidth can come out of a server and go into a server. We don't need the expensive giant video matrix because the network does that for us. Multi-viewers, I was talking to it's the JPEG XS folks about how their codec works. It's line-based. So they were talking about multi-viewer applications where multi-viewers skip every other line of the video in order to allow more sources to go into them. Because right now, if every source is, 12, 13 gigabits, that's a lot of bandwidth that has to go into making a 9 wall on a computer. But if you could cut that in half, all of a sudden you can double the number of pips in your multi-viewer, and there's lots of interesting things. But again, a multi-viewer at this point just becomes a program. And an LED processor is another program, and a screen switcher is just a program. Things take bandwidth in, things do compositing operations on GPUs on them, and they spit it back out. So to reduce the hardware complexity, this is my concept called Show-Kubernetes, a mashup of shows and Kubernetes, which probably isn't even the one you would use. But like, imagine that everything that you would ever have in your live event network was some kind of virtual machine or container. So you've got a bunch of machines, they're able to pass video in and out between them, and you need an application that does some real-time effects compositing. That could just be an app that's running on one of your machines that takes the video in, processes it as quickly as it can, and sends it out. If you look at the internals of what a screen switcher is these days, that's basically what they're doing in an FPGA. They're taking video in, they're applying processing, and they're spitting it back out, often multiple times through the same process. But with everything being software, you have the flexibility to define what those elements are. So if in the next show you didn't need screen switching, but instead you needed multi-viewing, that processor box could take in 4 signals, smash them down, and output 1. Everything is just another app or a program. And me as the rental shop, or me as the person dealing with equipment, I've got one thing I need to deal with. It's really fast computers with really fast networks. I don't need this boutique multi-viewer box for the 2 shows a year where somebody needs a fancy multi-viewer, or I don't need the very fancy screen switcher that does 120 hertz. I just need to use a little bit more resources on my computer that I'm running screen switching on. So I'm not locked into the product features of any given box. I have the ability to move software around. But of course, there's some challenges with 2110. And the big one right now for us is all the products that are on the market, or a lot of the products that are on the market, are just, there's a lot of converters. And converters don't really help me attain my goal of making everything computers, because you have a computer, it plugs into a converter to turn it into 2110. Then if you're going to go into a screen switcher, you've got another converter, which turns it back into video, which goes into the screen switcher, which on the output of that, you plug in another converter. And it's like you end up with this never-ending pile of little black boxes with, if you're lucky, PoE, but likely little wall warts. And then you can only plug 6 of them into a power strip. And it's a whole mess. But and another example of that is machines that have converter cards built in. It's like the Disguise system is one that I use a lot, and they have SMPTE 2110 IP cards. But the problem with their IP cards is they're just taking video in at the backplane, so that machine's still limited to outputting 4 streams. And it really didn't fix any of the problems. It just put a converter in a very fancy place where I can't knock it off a table, which is good. So again, one of the things that RiverMax and NVIDIA have done that's really wonderful is given me the ability to output that video directly from the computer. There is not a converter box. The computer has a network card, which I can use for other network activities like moving content and Unreal scenes around. But also, that same network adapter can send out, 16 streams of 4K video. So part of my dream is on the computer side, we're generating all the signals natively, and then on the LED side, we're consuming all those signals natively, and we don't have to have all these awkward conversion boxes. And we're getting to the point where we're starting to see LED processors adopt 2110, screen switchers adopt 2110. So we're getting there. It's not all completely generic compute boxes yet, but everybody's at least ditching the converters. So the other challenge of 2110 is uncompressed is very expensive and difficult. You end up with these. The unfortunate reality that Europe beat us to is the 12G SDI signal for 4K at 60 doesn't fit in 10 gigabits, which is the common network denominator that's easy to do. So you need a bit of compression to make that work. But if you're doing 4K 50 hertz, it does work. So they really dodged a bullet there. But for us, having to deal with the actual uncompressed data can really be challenging. Also, 2110 is kind of hard. There's not necessarily anywhere to plug in and monitor. If there is, the test equipment is You could buy a car. Um, and like, there's this question of like, how do we make our video experts into IT experts? I mean, we just figured out VLANs, and like multicast routing is very complicated. Like, I'm confused by multicast routing. Like, that's the next thing I need to go learn about. And even then, PTP can be really difficult. So to me, part of the journey of discovery that we're going on in live events is how do we make everything simple enough without making it too simple that nobody ever understands what's going on? Because you can kind of go either way. If you make things too simple, you can eventually find yourself in a situation where you're in some nightmare of a production and nothing's working and you have no ability to troubleshoot it because it's a literal black box. Or the other alternative is you have to like bring in really, really expensive like broadcast contractors and like figure out, which is unsustainable for those types of productions. So IPMX to the rescue. IPMX gives us many different new pieces that allow us to, that are going to help with some of those issues. So for one, compression is now an optional part, and they've mentioned JPEG XS. But of course, you know, you can also go create your own codec and open source it if you'd like, and hopefully people will adopt that. And I guess it's on the IPMX folks to figure out how to define and label. I think that's what part of the previous talk was about, how to define and label like what parts and what devices work with one another. But we're going to be able to more efficiently use our network bandwidth. If in order to do a 4K stream, we only need 10 gigabits, all of a sudden we don't have to buy these really expensive and difficult to use 25 gigabit switches, which means the cost of the gear goes down and the complexity of managing a huge network also goes down. There's kind of this thing with 2110 where once you start getting into multiple switches, you end up with a really complicated multicast workflow to make sure that you don't create bandwidth choke points. But if the original signals you're dealing with are smaller, then you hit that point later and you don't have to deal with it as often. So a 100 gig base switch could have, you know, 100 1 gig ports or 10 gig ports, but only 4 25 gig ports. You have the ability to spend that bandwidth more wisely and never leave the backplane of the switch, at which point you don't have to deal with nearly as much multicast nonsense. Monitoring multi-viewing also become easier with lower end signals. You can plug them into laptops with simple Ethernet adapters, or you could, you know, your multi-viewer can consume a lot more sources in order to display as much information as possible. There's also less reliance on PTP. IPMX gives you the ability to still use PTP for absolutely pixel accurate timing, but also it has an option for a less accurate frame accurate PTP sync. And part of what they do is they reduce PTP's bandwidth requirements, because typically in your SMPTE 2059-2 timing profiles, your PTP clocks are hitting your server 4 times a second. And the IPMX PTP spec kind of reverses that. It's once every 4 seconds for those clock sync pulses. So the reliance on having switches that are boundary clocks is less likely to be an issue because the amount of traffic you're dealing with is less in that case. So that simplifies a lot of the timing and troubleshooting related issues. Again, it's kind of kicking those problems down the road to bigger systems, but it allows you to do smaller and medium-sized systems without necessarily having to deal with all of that, which helps everyone get started in this world. Also, they require NMOS, which is great because one of the weird interop issues of 2110 is you can do any kind of control system you want. And that freedom and flexibility is wonderful if you're, you know, buying all your stuff from one large broadcast vendor who has their whole SDN controller and their whole architecture built around those programs. But for us, we're kind of in this weird world where it's like, I want to buy like maybe a small router to route like 24 sources. I can't afford a very, very fancy broadcast SDN controller to make that work. I really just want to use the built-in web interface that would come on a box like that. And, you know, you see some of the Blackmagic stuff is doing a really good job of that because they have the NMOS controller built into every little gizmo they make. So you're never going to have a shortage of NMOS controllers. Now, is it the best one? Probably not. But like, it's a jumping off point. It gets you started, and it beginning to train our technicians in understanding how to approach those sorts of systems. And the last little bit that IPMX has added is the ability to add a lot of HDMI stuff into 2110, which you could see that as a good thing or as a bad thing, depending on how much you hate HDMI. And if you come from the live events world, you probably hate HDMI a lot because there's all sorts of nonsense that's packed in there, which is there for good reason, like copy protection and security and authentication and HDCP and EDID. But like, I remember the transition from like analog video into the DVI world. And one of the things that the engineers really struggled with was EDID. And like we're still like 15 years later banging our heads against weird EDID problems with certain devices. And, you know, hopefully IPMX makes that better. But one of the cool things we get out of that is all the control protocols get bundled as essences into the 2110 stream. So you can do USB, 232, infrared, and GPIO for control. And that's starting to become a really interesting like KVM command and control system for us. Because all of a sudden, once you have video and USB, you can, you know, use the computer that you're sitting at on the big screen. So a little bit about how to make this work on a live event budget. This is where the NVIDIA folks have come in really handy. They've got RiverMax, which is a software platform for building IP video applications or other data transfer applications. And we've actually been using RiverMax for many years in live events because Disguise built their render stream technology on top of RiverMax. And what render stream allows us to do is have multiple headless render nodes generating Unreal scenes and sending those textures to our Disguise servers, which are then compositing them together onto LED screens. And what RiverMax does is it makes them not have to reinvent the wheel on SMPTE 2110, and instead there's like a knowable library that is supported that they can use. And another product that NVIDIA has is called RiverMax Display, which I have been using for troubleshooting and building my 2110 test lab in my bedroom, which is now torn apart because I'm moving. But it answers the question of like, how do you get someone to become an IP engineer is like practice, practice, practice. It's like going to Carnegie Hall. So what the RiverMax and RiverMax Display has allowed me to do is create and view signals on just using computers without buying any really fancy boxes. Like I had to buy the network switch and the network adapters on eBay. And, you know, I've been sending 2110 signals around my apartment for like 2 years now. And it's a weird hobby. And when people ask, like, there's this like whole community of like home lab people in the networking world who they usually really focus on storage and like really fast storage, and those are their benchmarks. But like my home lab is all about moving 4K video signals around, which is like a little bit more boutique and weird. So when I'm on site, do you have the thing? I ran into this issue where like I've got a laptop and it's got a Quadro in it because I bought a really expensive work laptop to do Unreal. And it's really easy to get a Bluefield 2 DPU and stuff it in a Thunderbolt enclosure. Normally the Thunderbolt enclosure is like this big and made of metal. So I made a little 3D printed one that allows me to just throw this in a backpack and not kill my back walking around with it. The laptop's still a little heavy. But what's wonderful about RiverMax Display or any of the other RiverMax applications is I can use their developer test applications to generate streams and plug them into an LED processor. So when I show up to our warehouse and somebody has this new SMPTE 2110 LED processor and they're like, well, does it work? And I'm like, okay, so what's your source? And they're like, oh, we don't have a source. It's going to go be installed at some broadcast company. They have the source. I can at least test it by plugging my laptop with Unreal in and just generating a scene that's 1920 by 1080 or 3840 by 2160 or even 4096 by 120. You can send unusual shapes of video and test that functionality. So RiverMax Display helps me solve my issue of having nowhere to plug in to QC a system by letting me move around a facility with my laptop and my little Thunderbolt adapter and inspect and generate test streams from wherever I am. So why is the cat streaming? Because IP is the future, and if you were smart, you'd be doing the same thing. Questions?